Hi, my name is Mike Gouline. I am the data architect at MX51. My talk today is going to be about our data journey, about the journey that we took to get to having a data practice, a data team, if you will. But instead of looking at it from a more chronological point of view, where I just describe everything that we did, I wanted to frame it in a more useful way so that people who are in a similar situation, they can use these learnings for their benefit. And the way that I thought to do it is to view this whole journey and this whole set of problems as one big optimization problem. And I even define it kind of loosely mathematically later on, but feel free to skip that slide if you're allergic to math. But there will be some architecture diagrams which I am told people like in these sorts of talks. So the first part is the background, where I'll tell you more about who we are and what the whole use case was. Then I'll define the optimization problem that I'm talking about. And then finally, I'll apply that optimization problem to a few of the decisions that we had to make along the way, such as storage, BI, and ETL. So first things first. Let's look at the overall architecture of what we do. So if you haven't heard of MX51, what we do is we provide services to banks to give them the tools to be able to compete with startups that already do similar things, but where they're the bank. So that might sound confusing, so let's look at an example. You might go to a coffee shop and you'll see one of those things that you see on the left here. They're called point of sale devices or electronic cash registers. So if you order something, they will likely put in all of the items that you want to buy in one of those things, whether it's an iPad or just a desktop with a touchscreen. And then when you say I would like to pay with a card or a phone or a chip in your brain or anything like that, they'll pull out a payment device, which you see in the middle there, which is called payment terminal or a pin pad, and they will manually enter the amount in there, which is obviously error prone and not a great user experience. So what we provide is libraries for POS vendors to be able to integrate into their software, and a piece of software that goes on the payment terminal to allow the two to talk. Simple as that. So when an amount is ready to be paid for, the POS sends it to the payment terminal. When the payment terminal is all good with the payment, you tapped your card or inserted it and put in the PIN. It reports back to the POS saying all good. What you don't notice when you're using it is that it connects to our backend through this gateway that you can see here. And behind that gateway is all of our microservices. Those microservices handle all of the events that come from the terminal, such as any diagnostics, Wi-Fi, printer is out of paper, things like that. Each of those microservices, as is the usual case, has its own database. In our case, they're all Postgres databases. And we have a few UI components that you see at the top there that connect to those microservices in the form of dashboards, and they display certain things, some of the events. If somebody calls up, one of the merchants calls up and says it's not working, so that the support team can help them with something rather than just saying, try turning it off and on again. And then there's the merchant dashboard, which allows the merchant to log in there and see how they're doing with their transaction volumes and so on. Eventually, though, we started getting some questions internally from product people, marketing people, and so on, that were very analytical in their nature and that required us to look at multiple databases. And obviously, because they're microservices and each microservice owns its own piece of data, you can't just do joins on them. And I mean, another fact about this is that you probably shouldn't be doing analytical stuff on your production databases, but in this case, you can't even if you wanted to. So we decided that it's time to build a data team. And the reason why I say team with the quotation marks is because currently, after just over a year, it's still just me, which, as you can imagine, drives some of the decisions because the resources are constrained. We have to prove things that are useful before asking for more. So when I say Melbourne office on the slide, we used to be a part of this company called Assembly Payments, which is based in Melbourne. We're based in Sydney. And back then, when we're the same company, which we no longer are, the Melbourne office started the data journey slightly before us. So it was a little bit of help to be able to compare notes, but because their backend was completely different, we couldn't just copy paste it. I want to briefly mention who I am and what I've kind of done before, just so that you understand where I'm coming from in terms of my thinking. I am definitely not a data scientist. I'm a software engineer. I see things the software engineer kind of way. And I started in MX51 in about 2.5 years ago. And what I started doing initially was actually building out the libraries for the POS software. We have a few that are based on each language. I published the first Java one and did a lot of work on the iOS one. Then I moved on to the microservices that we have that are specifically the terminals talk to. So still kind of keeping within that domain. And eventually now I'm handling the data that includes the data about those terminals, among other things. So it kind of painted a good picture here because I'm not just shoveling data that I don't understand. It gave me a good understanding of what that data is and where it comes from, which is useful. And now we get to the optimization problem that I promised you before. When I entered the data landscape, and I'm sure a lot of people watching this would have a similar kind of situation, similar story, is that you notice there's a lot of buzzwords. Nobody has any pricing on their websites. So you have to talk to sales, you have to spend time kind of defining what your problem is before you can get to it. You can't just say, in most cases, you can't just say, I'll sign up for a trial and, done. And the third thing that I noticed, which is kind of cheeky of some of the vendors that I've seen, where the vendors claim to do a lot of things that they're not particularly good at. So they would have one main functionality that they, got successful for. And then they add these kind of add-ons that technically, yeah, they do those things, but are they the best solution for that problem? Maybe not. So the game here really is make a decision, make it work with other decisions, repeat, rinse, repeat. And to me, that kind of sounds like an optimization problem. So the way that I drew it up was with a high-level architecture diagram where components are specifically what they need to be doing, what they're there for, rather than the implementation. And then we evaluate the possible implementations and choose one based on the metrics that we have. And a metric can be, I'll talk more about this in a second, but a metric can be just a continuous value from 0 to 1 or anything really, or just good, bad, medium kind of thing. Metrics can have weights. So some metric values could be more important to you, some can be less. And finally, you have requirements that basically just guard whether or not you're even looking at something. Because in some cases, if it doesn't pass your initial entry criteria, then you're not even going to compare it. You're just going to say, we can't use this. So that's a requirement. Some of them can actually be more complicated than that because some of those can be both a metric and a requirement, such as cost. Because you may care about, if you can afford something, you may or may not care about how much it's worth, depending on whether or not you can reuse the remainder for other tools. And then you have immutable requirements, which are things that will never change in the foreseeable future, such as, if you're in the financial industry, data sovereignty rules aren't going anywhere. And then you have the mutable ones, where potentially you might have a budget that's too limiting and you can't afford something at the moment, but later on, you might be able to afford it. So if you like some tool for, it does the job wonderfully and you would love to have it, then that becomes, when you relax that requirement of cost, that becomes your desired future state that you want to get to at some point. And this will become clear why we care about this slightly later. The metrics can be up to you. They really depend on what you're trying to achieve. But for me, metrics were business value, no-brainer, top priority, because otherwise, why even bothering? Then you have compatibility with the current state, which is stuff that you already have. Compatibility with the future state, which is where you're going in the future, or you think you want to be going in the future. And then obtainability, how hard it is, how many contracts do you have to sign, how many salespeople do you have to talk to, how much time do you have to, spend on reviewing it in your legal and things like that. And this is the formal definition that feel free to skip. It doesn't really add anything to it. This is just me being nerdy. But the goal here is to maximize the sum of all of your metric values multiplied by all of your weights. That's essentially it. So this expression here, you're saying we want to get the highest possible combination of those things and then the highest possible combination of all of the components. Now we get to applying the theory. And again, this is up to you. You can just say, it's just the vibe of it, if you get the reference. Or you can, painstakingly go through each one, work out what the value is, work out, multiply it by the weight, and then provide that report when you're presenting your decision. This is the architecture that I was working with. Simple as possible. So these are the databases that contain all of the source data. We need something to do the ETL. We need somewhere to store the results of that, and then we need something to visualize it. That's pretty much it. So we look at each one separately. We start with storage because it's kind of the biggest decision, because you don't want to be doing migrations if you move away from things. So option one was quite a popular one, data lakes. And when I say data lakes, I mean you could either do just an S3 bucket with something like Athena to be able to query things on top of it, or you can go all in on something proper like a Delta Lake if you're using Spark. And the compatibility here is pretty good because you just dump everything in that flat storage. So almost everything supports something like JSON or Parquet, all good. Compatibility with the future state, however, and I haven't mentioned this before, because we provide our services to banks, we're kind of slightly dependent on what cloud the bank is using. Currently, we're on AWS, but if the next bank comes along and they're on Azure or they're on Google Cloud, that's where we'll have to be, and that's what we'll have to support. So here you'll see that Athena is easy for obtainability because we already have AWS, but it's bad because if we go to Azure or to Google, we'll have to come up with either a comparable kind of counterpart service there, or we're going to have to find one that's cloud agnostic, such as Databricks with Delta Lake, which would require a separate agreement. Option one was using the kind of cloud vendor specific warehouse offering, such as Redshift for us. The cost part of it was not ideal because if you've used it before, you know that it requires you to define static compute that's always there. So you kind of need to know how much people are going to be using it, which if you're building out a brand new team and if you're in a startup, you don't really know. It might be a hit and everyone might be using it all the time for everything, or it might just be particular people, in finance who need that specific feature there. So it's not really cost effective, at least for our use case. Compatibility is good because it's the same cloud, but again, bad because it's the same cloud. So if we go somewhere else, then we're going to have to do the full migration of all of the tooling to Azure Data Warehouse, I think it's called, and to BigQuery on Google. And then the option that we ended up going with, which is Snowflake, the reason why we went with it is because, first of all, it's affordable and it kind of usage-based, so it grows with you. If you use a lot of heavy compute, you pay a lot of heavy money. If you don't use a lot of compute, then you don't pay a lot of money. The compatibility is pretty good because they're generally pretty well respected in the community. So a lot of things work with them just out of the box, like BI tools, ETL tools. There's always an option to connect to Snowflake. And the main thing here is that it's cloud agnostic because it supports all three major clouds. So regardless of whether we go to Azure or Google, we'll still be able to spin up a Snowflake instance. And obtainability, technically you need a new agreement, but we kind of cheated because our Melbourne office at the time, since they started 6 months earlier, they already went with Snowflake and they already had an agreement that we could kind of piggyback off of. So excellent. That was great decision. I was giving a thumbs up. I think it was off camera before. Now we get to the visualization, which is kind of also important because unless you have a good way of visualizing all of the data that you've collected and transformed, it's useless to non-technical people and even technical people, because what point of collecting it if you can't get insights out of it, right? So option one that we actually did try was QuickSight for the same reason. It's in the same cloud. Here it is. But unfortunately, the compatibility with Snowflake wasn't so great, at least a year ago, because it tends to be more targeting, AWS specific tools such as Redshift, things like that. And you have the same problem of what if we go to Azure? What if we go to Google? Although the obtainability is obviously easy because it's the same cloud. So that was unfortunately out. Tableau, which I hear from a lot of people seems to be the industry standard, because every time you see a dashboard published somewhere, you recognize that it's visualized in Tableau. However, the cost was not great for us because, being quite constrained on resources, I'd love to get hold of it, but it was slightly out of my team's reach. But the compatibility and all of that was good because it's, cloud agnostic, and it supports Snowflake, it supports Salesforce because they're the same company now. Excellent. But there's that issue of signing a separate contract and annual pricing and a lot of money. So that was kind of our, and still is our kind of desired future state. But what we ended up going with is kind of a bit of an open source DIY option called Metabase, which is free, it's open source, you host it yourself. It supports Snowflake, among other things. Because you host it yourself, it's cloud agnostic, so you can put it on Kubernetes, you can put it on whatever you want. And no contracts, you just download it. You have to manage the deployments and things like that, but kind of a small price to pay, honestly, because we're spending, I don't know, like $100 US per month on hosting it. So that's nothing. And with our current demands, it's doing its job pretty well. And then finally the ETL part, which I find to be the hardest decision because there's so many different sources and so many different tools that you have to find a tool that, first of all, you can afford because they're really, really expensive, but also that covers all of the sources that you have now and all of the sources that you're planning to have in the future, which sounds kind of impossible. So option one is just the collective cloud-based, all-in-one solutions, not specifically Fivetran, but Fivetran, Stitch, Illuma, all of those things. The reason why I say Fivetran and Stitch is because our Melbourne office at the time were using them, so they were the kind of specific options that we considered. Downside for us, very expensive, so couldn't fit it in the budget at all. And at least back then, I don't know if it's changed, but the way that they work is they usually host it themselves, and you just provide an SSH tunnel into your VPC behind your firewall where they can connect to it and extract all of the data. That's unfortunately really bad because we can't control where it's hosted geographically, which is a requirement for us. So that was unfortunately out even before, the contracts and things. Option two was Matillion, and the reason why I say Matillion separately from all of the others is because unlike the others, you can host it wherever you want. So you can just get it off AWS Marketplace and you can just host it there in your VPC behind your firewall. And this is still, a potential option that we're considering, but at the end of the day, we ended up going with just good old Glue. And I hear you wondering why we went with this, but not all of the other AWS specific things. Well, the reason is, first of all, it's very, very cheap. So even if you go in and then migrate out, you're still saving a bunch of cash. But also, because it's essentially a managed Apache Spark service, what we do is we just write all of the Glue code as just PySpark code, that if we have to move it somewhere, we'll just find another Spark provider, such as Databricks or whatever the Azure and Google ones are. So easy, it kind of all blends in together. And also, one kind of appendix to this is that eventually, when we were happy with Glue and we were starting to think, how do we make it a little bit more kind of mobile and manageable? So we decided to separate out the transformations with dbt, which is the data build tool. So picture I'm trying to paint here is that you're not really locked into that one decision. You can then do an iteration on the iterations and on the iterations, which is what we did here, because the Appendix 2 is we also decided to separate out the loading, because Glue was originally just loading things into Snowflake through the Spark connector, because there's no native way of loading into Snowflake, so you have to use the connector. But again, to make it less of a bottleneck and to separate the concern, we started using external Snowflake stages, which is working really well. So what I'm trying to get to here is that although this is our journey and your mileage kind of may vary, what you should be thinking of is that although you can use a framework for decision making for anything, what you really should be using it for is decisions that you have to then justify to the rest of your team, to your management, to your CEO or whoever you need to justify it to. Hopefully this framework, kind of loose framework that I came up with, is useful to you. And if it is, feel free to use it. Consider it open sourced. And that's all I had. If you'd like to hear about anything else or ask me about anything else that's related to this, here are my contacts, and the recording and the slides, if you missed something, will be available on my website that's at the top there. Thank you for your attention.